Good day, Philippines. Hello, Region 1. Aloha, San Carlinian learners. Airing live from the mango bamboo capital of the Philippines, San Carlos City. You're tuning in to CCN Broadcast Center, a virtual home of every SDO-SEC learner, where passion is the key. Learning paves the way. With our division mantra, developing creativity, maximizing versatility. This is your CCN Broadcast Center. CCN Broadcast Center, a virtual home of every SDO-SEC learner.
Good morning, all viewers, especially to all grade 10 learners who are now watching here in Carlos and Carlin Network. This is Sir Ver from Speaker Eugenio Perez, National Agricultural School, your teacher broadcaster for today. So welcome grade 10 mathematics learners for this grade 10 mathematics class. Okay, I hope you are doing great. So before we start, so be sure that you have with you your self-learning modules, paper and pen, for you to effectively participate during our discussion and activities later. Our topic for today is all about permutation of objects. And these are this is the first competency of third quarter of grade 10 mathematics. So this is for week 1. And these are our learning objectives. First, define permutation. Second, illustrate the permutation of objects using the systematic listing method, the tree diagram, and the fundamental counting principle. And third, appreciate permutation as vital part of our daily life. Okay. To start with, let's have this warm-up activity. The title of this activity is, Does order matter? Agree or disagree? Study the following situations given below. In your piece of paper, draw a happy face after each item if you agree that order is important in the given situation. If you don't agree, draw a sad face after the item. Okay, first item, forming 3-digit numbers from the digits 1, 2, 3, 4, and 8. So agree or disagree? Okay, if you agree, then you are right. Okay, how about selecting 5 students from a class of 40 to form a group? So agree or disagree? Okay, you're right. So order is not important in this situation. So it's a sad face. How about arranging the letters of the word heart to form new words with or without meaning? Okay, agree or disagree? Okay, you're right. Order is important in this situation. So it's a happy face. Next, forming different triangles out of 5 points on a plane, no 3 of which are collinear. Agree or disagree? Perfect. Okay, order is not important in this situation. So it's a sad face. And then finally, choosing 3 out of 4 questions to answer. So agree or disagree? Great. So order is not important in this situation. So it's a sad face. Okay, so I'm sure you are now ready to proceed with the next activity. So the title of this activity is, Arrange Me Please, item number 1. So arrange the letters A, B, and C in a row, then list the possible arrangements and count the number of possible ways these 3 letters can be arranged in a row. Okay, we have the second item. Okay, form 2-digit numbers using the digits 1, 2, 3, and 5 without repeating any digit. Then, list the possible 2-digit numbers that can be formed and count the number of two-digit numbers that can be formed. Okay, are you done? Okay, let's have your answers. Okay, wait. Okay, for the first item, okay, the question is, what are the possible arrangements of the given letters? Okay, we have ABC, ACB, BAC, BCA, CAB, and the last one is CBA. So how many possible ways of arranging these three letters in a row? Okay. If you count all the enumerated arrangements, so we have 6. So there are 6 ways of arranging these three letters in a row. Okay, how about the second item? Okay, wait lang ah. Okay, from the two-digit numbers using the digits 1, 2, 3, and 4, and 5 without repeating any digit, okay, do the following. Okay. What are the possible two-digit numbers that can be formed? Okay, you have here 12, 13, 15, 21, 23, 25, 31, 32, 35, 51, 52, and 53. Okay, we have enumerated all the possible two-digit numbers. So how many of them? So actually there are 12. Two-digit numbers that can be listed or enumerated. So, for your next activity, okay, to deepen your understanding, okay, for you to have a better understanding of our lesson, so the title is Guess What? I want you to study the following 3 figures on the slide and answer the succeeding questions. Okay, are you ready? Based on the given figures above, what concept is illustrated? So I have given you there a hint. Okay, given the letters P, M, A, and N. Okay, what is that one word in which this concept is illustrated? Okay, you're right. The correct word, so I'm looking for the word permutation. Okay, take note of the word permutation. Okay, how about based from the figure above, what is permutation? Okay, how do you define permutation? Anyone from the class? Okay, very good. Okay, permutation is the arrangement of objects in a definite order. Okay, take note, in permutation, order is important. No? Okay, order is important. Okay, we take into consideration the order. Okay, next. In figure 1, what method is used in enumerating the possible arrangements of the given letters? Okay, as you can see, there are branches. We start with the point and then it branches out. Okay. If your answer is tree diagram, then you are right. Okay, tree diagram. In figure 2, what method is used in enumerating the possible two-digit numbers that can be formed from the given digits? Anyone? Okay, correct. So, the right answer is systematic listing method. Okay, this is illustrated in this figure. How about in figure 3? What method is used in finding the number of possible ways of arranging the 5 children in a row? Okay, can you guess what is the right term for this? Great. So the correct answer is fundamental counting principle. Okay, it is illustrated in this figure, no, example. Okay, can you give some situations in your home or in school where in which permutation can be used? Okay, anyone? Okay, very good. Okay, there are a lot of application of this concept of permutation. Okay, let me give you this example one to demonstrate this concept of permutation. Okay, how many three-digit numbers can be formed using the digits 1, 5, 6, and 7 if repetition of the digits is not allowed? Okay, so take note that there are three counting techniques we have just shown a while ago. So we have the tree diagram, the systematic listing method, and the fundamental counting principle. Okay, we will apply these three counting techniques. Okay, let's have the first one, the systematic listing method. Okay, in this method, class, okay, we are going to enumerate all the possible three-digit numbers starting with the smallest number. So that's why it's called a systematic listing method. Okay. What is the smallest three-digit number that can be listed? Right, 156, and then followed by 157, 165, 167, 175, 176, 516, 517, 561, 567, 571, 576, 615, 617, 651, 657, 671, 675, then we have what? 715, 716, 751, 756, 761, and 765. So all in all, if you count, there are 24 of them. Okay, this is by using the systematic listing method. Okay, we can also solve this problem by using the tree diagram. Okay, for tree diagram, we can start with a point or a dot, and then take note that we are asked to solve this, enumerate all the three-digit numbers. So we have the hundreds place, tens place, and the ones place or the units place. Okay, we branch out into 4 because we are going to fill up the hundreds place, and we have 4 options for this. Either we use the digit 1, 5, 6, or 7. So we have 4 options for this. Okay, assuming we use the digit 1 for the hundreds place, then to fill up the tens place, we have 3 options. That's why we have 3 branches. So either we choose 5, 6, 7. And then, okay, after filling up the tens place and the hundredth place, okay, let's say we use 5 for the tens place. So for the units place or ones place, we can either choose 6 or 7. Okay, and we have the numbers 156 and 157. Okay, what if we use 6 for the tens place? Okay, what are the possible choices for the ones place? Okay, we have 5 or 7, and the possible three-digit numbers are 165 and 167. Correct. And then, if you use 7 for the tens place, so for the ones place, you have only the digit 5 or 6, and we can form the numbers 175 and 176. Okay, we continue the process for this to complete the required three-digit numbers. Let's say we use 5 for the hundreds place. So what are the possible digits to be used for the tens place? Actually, there are 3 of them, either 1, 6, 7. Okay, we continue the process, the same as we have done a while ago. Okay. Okay, you just continue, and then you trace to list all the numbers you have formed. Okay, we complete all the possible 3-digit numbers. Okay, and then you trace to enumerate all. Okay, we have listed all the possible 3-digit numbers. Okay, this is complete. And if we count, as you can notice, there are also 24 3-digit numbers that can be formed as we have obtained using the systematic listing method. Okay, we can also use the third method, which is the fundamental counting principle. Okay, what is fundamental counting principle? Okay, let me define first what is this fundamental counting principle, or FCP. If one activity can be done in P ways, a second activity can be done in Q ways, and a third activity can be done in R ways, then the 3 activities in succession can be done in P times Q times R ways. This is known as the fundamental counting principle, or multiplication of choices. Okay, let's proceed with the solution of that problem. Okay, since we are required to form 3-digit numbers, we have 3 activities to be done. We are going to fill up the hundreds place, tens place, and the units place, or the ones place. Okay, how many options do we have for the hundreds place? Okay, we have 4 options. Either we use the digit 1, 5, 6, or 7. So, there are 4 options. How about the tens place? Okay, take note a while ago that repetition is not allowed. So, we have already used 1 digit for the hundreds place. So, there are only 3 remaining options for the tens place. Okay, and then for the ones place, since we have used already 2 digits for the hundreds place and tens place, we have only 2 digits for the 2 remaining options for the ones place. So we have 2. And we multiply the choices to obtain 24. Okay. So as you can see, class, any method will give you the same result. So remember that there are many ways to solve a problem. Okay, next example, to deepen our understanding, how many permutations are there in the word alive? Okay. Compute how many possible arrangements are there even without meaning, with or without meaning. Okay, take note, we are going to use all the 5 letters to form a word with or without meaning. So we will just rumble those letters. Okay. The tree diagram and the systematic listing method is impractical to use in this problem because it is time consuming and there is a greater chance of committing mistake. So instead, we use the fundamental counting principle to solve this problem. Okay, we have 5 letters to rumble, so we have 5 activities. The first box to be filled up is the leftmost box. So we are going to select from those 5 letters. So any letter can be used for the first box. Okay, we have 5 choices. And then the next box to be filled up, so we have only 4 choices since we have already used 1 letter for the first box. Okay, third box. There are only 3 remaining letters to choose from. So we have 3 options. Next, the next box. So there are only 2 options since we have used 3 letters already. And of course, the last one, the last box, we have only 1 letter remaining. So it's only the last one. So 1 choice only, so 1. So we multiply the given choices to obtain 120. So how many permutations are there in the word alive? There are 120 of them, 120 permutations. Okay, a while ago we have discuss the importance of this permutation in real life. So let's say in making your passwords for your cell phone, 4-digit password, or creating your personal identification numbers for your account, ATM account. So actually we are using the concept of permutation. So in school, in making your seat plan, how many seating arrangements are possible? How many ways can we arrange the books in the library, in the shelf? How many RNA sequences are there in terms of in biology? So we can determine how many RNA sequences are there. In computer, the algorithms, the arrangement. So we can use the concept of permutation. Okay, another example of this application is in scheduling. So just like in the airport, just like in Naian International Airport, okay, we have a lot of domestic travels, international travels, so we have to do scheduling. And this permutation is a big help for this. Okay, these are some just application of permutation. It's part of our daily life. Okay, so let's have this activity. So where's the right place for me? So this is the title of our activity. I want you to answer the following questions. Okay, question number 1. 5 students, Alan, Ben, Charlie, David, and Edgar are to be seated in a row of 5 chairs. In how many ways can they be seated? Okay, in how many ways can they be seated in a row or straight line? Okay, can you give me the right answer for this problem? Okay, we use the fundamental counting principle. For a quick solution or answer, we use this fundamental counting principle. Of course, there are 5 chairs in a row, and there are 5 students in the class. Okay, the first chair there can be seated by any one of them. So we have 5 choices for the first chair. Okay, assuming Alex is seated on the first chair. For the next chair, we have only 4 remaining students to choose from. Okay, assuming again Ben is seated on that particular chair. For the next chair, we only have 3 students to choose from. So we have 3 choices. Again, if Charlie is seated on that place, the next chair can be occupied by either David or Edgar. We have 2 options for the next chair. Okay, let's say David is seated on that particular chair. The last student has no other choice but to sit on the vacant seat. So we only have 1 option for this chair. Okay, we multiply all the choices. 5 times 4 times 3 times 2 times 1, and we get 120. So there are 120 possible seating arrangements for these 5 students to be seated in a row. Okay, next. Okay, if you will create a 4-digit password for your cell phone using the digits 0 to 9, how many passwords could you make? Okay, it is silent. It does not mention whether there are repetitions or not. But in creating passwords, so we can repeat the digit. Actually, repetition is allowed. So there are 10 digits to choose from. Since we are required to form a 4-digit password, then, using fundamental counting principle, it's good if we make use of that diagram. So we draw 4 boxes for the 4-digit. The first box can be filled up by any of the 10 digits. So we have 10 options, and repetition is allowed. So again, the next box can be filled up by any one of the 10 digits. Same is true with the third box. We can again repeat the digits. So there are again 10 choices for the third box. And lastly, for the third slot, again we can repeat the digits. So we have still 10 digits to choose from. Okay, if we multiply all the choices, we obtain 10,000 4-digit password. Imagine, no, if you list down all, it's impractical to list down all of these 10,000 passwords. And we cannot use tree diagram. So, the only practical solution is the fundamental counting principle. Okay, so to assess your learning, I want you to answer these 5 questions. So prepare your pen and your paper, and you give your answers in the chat box. You give the letter only. Read and understand its item, then choose the letter of your answer and write it on your answer sheet. Okay, first question. In how many ways can 5 books be arranged on a shelf? Is it letter A, 50, B, 100, C, 120, or is it letter D, 180? Okay, if your answer is letter B, then you are correct. If your answer is letter C, then you are correct. Okay, 5 times 4 times 3 times 2 times 1 is 120. So it's letter C. Okay, how about this problem? Using the letters of the word module, how many 4-letter words with or without meaning can be formed? Is it A, 240, B, 360, C, 400, or is it letter D, 420? Okay, what is your answer? If your answer is 360, then you are correct. So the answer is letter B. Okay, next. How many 4-digit numbers can be formed from the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 if repetition of the digits is allowed? Is it letter A, 4,200, B, 4,536, C, 10,000, or is it letter D, 9,000? Okay, show me your answers. The correct answer is 9,000. So it's letter D. Fourth question. In how many ways can Aling Rosa arrange her 6-potted plants in a row? Is it letter A, 480, B, 520, is it letter C, 712, or letter D, 720? Okay, what is your answer? If your answer is letter D, then you are right. So it's 720. Okay, the last question for this assessment is, there are 12 athletes joining the Baguio Marathon event. How many ways can the first, second, and third placers be chosen? Is it letter A, 1,320, B, 1,200, C, 872, or letter D, 720? Is it letter A, B, C, or D? So if your answer is 1,320, then you are correct. So perfect. So congratulations. So I know you have learned a lot from this lesson. So if you have any comment, so just comment in the chat box. And see you again in the next video episode. So again, this is Server of SEPNAS saying, correct practice makes perfect. God bless everyone.
Good day, Philippines. Hello, Region 1. Aloha, San Carlinian learners. Airing live from the mango bamboo capital of the Philippines, San Carlos City. You're tuning into CCN Broadcast Center, a virtual home of every SDO-SEC learner, where passion is the key. Learning paves the way. With our division mantra, developing creativity, maximizing versatility. This is your CCN Broadcast Center. CCN Broadcast Center, a virtual home of every SDO-SEC learner.